Hello and welcome to another online lesson for GCSE Physics. Today's learning intention is to calculate the speed of an object. Now the success criteria for today's lesson is to know approximate values for the speed of different activities such as walking, running and cycling, and to recall the equation speed equals distance divided by time. Now, one of the first things that we're going to need to do is to estimate the following speeds. How fast do you think you will be able to walk, run, or cycle? Now, I would like you to write down what you think before I tell you the answers and give your answers in units of meters per second. Now, according to the exam board, and of course these numbers are approximate because it would vary from person to person depending on different factors, but a typical walking speed for the average person is 1.5 meters per second. Now, in terms of running, we can normally run twice as fast as we can walk, so typical running speed comes out as 3 meters per second, and typical cycling speed is usually quoted as being 6 meters per second. As I said earlier, there are variations to this. It would depend on a number of factors that we'll discuss shortly, but these typical values are what the exam boards say we need to know. They could ask us what they are in the exam, or they could ask us to do calculations where we would need to remember what these speed values are. Now, there's a lot of factors that affect how fast we could run. The first factor that I'd like to talk about is the distance that we are intending to run. If you're intending to run 100 metres, which is a relatively short distance, then obviously you could expect to run that much faster than you would do if you were to say run a marathon, because you'd need to keep running for much longer, so you would have a lower average speed. Another factor that affects how fast we can run is our level of fitness. Generally speaking, the fitter somebody is, the faster they are likely to be able to run. A very similar factor will be the age of the person, again because you would expect a younger person to be able to run at a higher speed than an older person. And then the final factor that the exam boards say that we need to be aware of is the terrain that we are running on. Now, terrain just means basically what the ground and what the surroundings are like. So if you were running on a running track, you could expect to run much faster than you would do if, for example, you were running through a muddy field or a stream, as you can see the lady on that Tough Mudder picture there is doing. Now, we've got a worksheet that I would like you to have a go at here, so please pause the video, write down your answers to the questions, and then press play when you are ready to mark the work. You can see on the board now the first 2 questions from the worksheet, and here is questions 3, 4 and 5. Press play when you're ready to go over the answers. So question number 1, what is typical cycling speed? Tick 1 box. There was 4 options provided for us. The correct option is 6 meters per second. Question number 2, the diagram shows the journey that a student takes on their way to school. Now we've been asked to draw on the diagram an arrow to show the displacement of the child. Now displacement we talked about in our last video, which was about scalars and vectors. Displacement is a vector, so we can show it using an arrow. Now because the student has gone from home to the school, we would expect the displacement to be drawn going from home to the school, so you can see that I've drawn a straight line or a straight arrow with the tip of the arrow being at the school. We were then asked to suggest the speed that the student will walk to school at. Now typical walking speed is 1.5 meters per second. Question number 3, an electric wheelchair moves 2/3 as quickly as a typical person will walk. We've been asked to determine the distance that the wheelchair will then move in 4.5 seconds. To do this, we would use the equation speed is equal to distance divided by time, but we would need to change the equation around. Now, to change the equation around, we could use an equation triangle, and when we draw the equation triangle, we would have distance on the top because distance is being divided by time. So that means that distance comes out as being speed multiplied by time. The speed of the person will be 1 metre per second because 2/3 of 1.5 is 1, and then we would times that by 4.5 to get a final answer of 4.5 metres. Question number 4, we were asked to list 4 factors that will affect how fast a person can run. Now, we went over those a few moments ago. We could have said the age of the person, we could have said the level of fitness of the person, the terrain that they are running on, whether they're on a running track, for example, made out of tarmac, or whether they're running through a field, etc. And then finally, we could have said how long a distance they are going to run for. There are, of course, other suitable factors that we could have given. One that always pops to mind for me is the gradient that they are running on, because if they're running uphill, they're likely to run slower than going downhill. And then finally, question 5, how many times faster is typical cycling speed compared to typical walking speed? To do this question, we need to know that typical cycling speed is 6 metres per second, typical walking speed is 1.5, so we would do 6 divided by 1.5, which gives us the correct answer of 4 times faster. We now have some summary questions that I would like to have a go at. The summary questions on the left-hand side are pretty typical questions about this topic. The ones on the right-hand side are the harder questions. Please pause the video and press play when you're ready to go over the answers. So, for the first question, we were asked to sort these quantities into a table of scalars and vectors which I've drawn there in green. Now, distance does not take into account direction, and so distance would be a scalar quantity. Force, on the other hand, does take into account direction. We can represent it using an arrow, and so force would be a vector quantity. Speed, again, does not take into account direction, and so we say that speed would be a scalar. Displacement, as we saw on the worksheet previously, displacement can be shown with an arrow and so is a vector quantity. Now, velocity is also a vector, that's the vector equivalent of speed. Time, on the other hand, would be a scalar, because if something lasted 3 minutes, for example, you wouldn't say it was 3 minutes southwards, or you wouldn't say it's 3 minutes in that direction. The time itself is just a scalar. Mass, likewise, the amount of kilograms or the amount of grams that something is a scalar. And finally, current would also be a scalar. Current, of course, we did a whole topic on electricity earlier on in the course. Now, for question number 2, we were asked to explain the meaning of the word velocity. Well, velocity is speed in a given direction, and it is a vector. I would actually include both of those in your explanation of the word velocity. Typical running speed of a person, no issues there, that should be nice and easy, 3 metres per second. But a car on a motorway we haven't actually discussed. Now, what the exam board would be looking for here is you to estimate a sensible number. So there would probably be a range of acceptable answers. However, the best answer that I think you could give would be 30 metres per second. The reason being that most cars on a motorway would travel about 70 miles an hour, and 70 miles an hour is the equivalent of 30 metres every second, 30 metres per second. Question number 4, a man walks 2 metres per second, he walks for 30 seconds, how far has he walked? We want to work out the distance, so we would use the equation speed is equal to distance divided by time, but we would rearrange it using a triangle, and when we do that we would do 2 times 30 to get the correct answer of 60 metres. Now, for the harder summary questions, we were told a runner runs a 400 metre race around a track and that person finishes at the same place that they started. That means that the overall displacement of that person is actually 0 because they've ended up back where they started. However, the total distance travelled by the runner is instead 400 metres. Then question number 2, a man says that he drives his car around a roundabout at a constant velocity of 10 metres per second. And we were asked, is that actually possible to do? Explain your answer. This would probably be 3 marks. The first mark is for pointing out that no, this is not possible to do. The reason being that they've said he goes at a velocity of 10 meters per second, a constant velocity. Now, velocity is a vector, which means it takes into account direction, but when you move in a circle, the direction is constantly changing, and so therefore you can't have a constant velocity because the direction changes, so this is not possible. Now, to finish today's lesson, we're going to have a look at an exam question that's worth 6 marks. On the exam paper, this would likely have a whole page of lines for you to write on. They'd be expecting quite a bit of writing from us. It says competitors are taking part in a triathlon race which involves running, swimming and cycling in immediate succession over a 50-kilometre distance. Describe the factors that may affect the eventual outcome of the race, and your answer should include the typical speed values at the various stages and what other factors may affect the time of all the competitors in the race. Pause the video, write down your answers and then press play to mark your work. Now, the first 3 marks for this question come for stating the typical speed values for each of the stages. Now, running we know is 3 meters per second. We've done that quite a bit today already. Likewise, we know that cycling speed is 6 meters per second, but at no point have I mentioned swimming to you. Now, the exam board would have wanted you to have had a best guess at this, kind of like estimating, coming up with a sensible answer. A sensible answer would probably be 2 meters per second, but the exam board would accept between 1 and 2.5. The idea being that you need to realise that swimming speed is going to be lower than what running speed is, which was 3. So anything really in the region of 1 to 2.5 would be fine for that. Now, we would then ask for what factors would affect the time of the competitors in the race. The first factor that I would think of is the distance that each activity is done for. Because if the majority of the distance was done while cycling, you would expect the time to be much shorter than if, for example, most of the distance was swimming, because naturally you cycle faster than you swim. Other factors that we've already discussed in this video that you should have looked to include in your answer would have been the terrain that they are running on or the terrain that they are cycling on, whether they are running up or downhill or cycling up or downhill, the age of the competitors involved and the fitness level of the competitors involved as well. Any 6 of those 8 points that I've put on the board there would have got you the 6 marks in the exam.